I got an important lesson today about functions, everything you need to know about functions, and then some. Take some good notes, hang in there. Really important stuff today. First of all, what is a function? A function, basically, in real life, for example, describes a dependence of one quantity over another. For example, height usually is a function of weight. The temperature is a function of the date. The date affects what the temperature is. Just like up here, weight, a lot of times, not all the time, affects how tall you are. Cost of mailing a package is a function of weight also. The more a package weighs, the more it costs. So this right here, the cost of mailing depends on the weight. The temperature depends on the date. The height, most of the time, depends on weight. All right, so a function is when describes the dependence of one quantity over another. Now in math, we think about it this way. Here's the real math rule. A function is a rule, which is an equation, that assigns each element x in a set A exactly one element called f of x. F of x is a fancy notation for y in a set B. In more plain language, every x has exactly one y assigned to it. Every x has exactly one y. The y depends on the x. X is the independent variable. Y, or f of x, which is the same thing, is a dependent. Dependent variable depends on the x. All right, let's look at a couple here. This one says find a few. We probably won't find all these, but it says first one says find f of -2, which means what is y where x is -2? You see the function is called f of x. Okay, so what is y where x is -2? All you have to do is plug the -2 in for the x's. Let's see what happens here. -2 squared is 4 times 3 is 12. Minus 2 is 10. Minus 5 is 5. Let's do a couple more. F of 0, same process. Plug 0, substitute 0 in everywhere you see an x. It's like this. That one's going to equal -5. So if x is 0, y is -5. If x is -2, y is 5. The y depends on what the x is. F of 4. We'll do this one to stop on the slide. 3 times 4 squared minus 4 minus 5. 4 squared is 16, times 3 is 48, minus 4 is 44, minus 5, 39. All right, so that shouldn't be a big deal. Find the value of y if they give you x. All right, this is called piecewise, or piecewise functions. This says a cell phone costs $39 a month. The plan includes 400 free minutes and charges 20 cents for each additional minute of usage. Not hardly anybody does this anymore, but when cell phones first arrived on the scene, this was very common. The monthly charges are a function of the number of minutes used. So your cell phone bill, back in the day especially, depending on how many minutes you use. So the first one says, what if we use 100 minutes? Okay, this is called piecewise because there's two different functions in one. Right? Where would 100 fit? 100 fits in between 0 and 400, so that would be my y, my 30. So it'd be $39. The second one says 400. Okay, so I'm going to find out how much it would cost me if it was 400. Well, that first one also says less than or equal to 400, so it would still cost $39. So you might as well use 400 minutes. The last one says, okay, what if I use 480 minutes? All of a sudden, that puts me in a different category. It puts me here at 39 plus 20 cents times really 480 minus 400, which represents how many minutes over 400, which is 80. So if you punch it in your handy dandy calculator, which I'm doing right now, 39 plus 0.2 times 80, and you get, that wasn't right. Fixed it. It's going to end up being $55. I accidentally on my calculator just and I was trying to punch it in real quick while I'm making the video, and I was hitting a time sign right there instead of plus, and I was getting something huge, which I knew wasn't right. So $55 if you go 480 minutes. But that function, again, that's called piecewise, and you just got to look at which function do I plug the number into. All right, evaluating a function, just did this a minute ago. This is a biggie though. I need to really walk you through this one, especially when we get to part D. First thing it says is find f of a. All right, f of a, I'm just going to plug in the a, 2a squared, 3a minus 1. Right. Second part, f of negative a. If I plug in a negative a, that's still 2a squared, but the 3a becomes minus 3a. The 1 is still minus 1. So the only thing that changes is the middle term, because if you square negative a, it's still positive. All right, then it says define f of a plus h. It's going to take a second here. I got to take a plus h and square it. I'm going to do 3 times a plus h minus 1. Okay, so I'm going to work that out. I'm going to square this parentheses right here, which we talked about that earlier in the year. Square the first one, multiply together, double, square the second one. On this one, let's distribute the 3. All right, now I'm going to distribute this 2 in the front. 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. No big deal there, right? Just all that stuff. Okay, here's where we're going. You're going to see this last thing right here, this right here, show up all year long in different sections. That's called the difference quotient. And I'm just going to work it out here. It says do f of a plus h, which we just found. There's f of a plus h right here. So I'm going to put all that up here. 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Then it says minus f of a, which you have one or two options. I can do minus this, or I can just put that there because that is negative a. So I'm just going to put the negative a up here and go 2a squared. Hang on. I think I will do this. I think I am going to do minus f of a. If I do minus this, first function, that changes all the signs. It makes it negative 2a squared minus 3a plus 1. And all that is going over h. That looks crazy. It looks huge. It is, but watch what happens. I'm hoping something pretty good is going to happen. First of all, the 2a squareds cancel. The 3a's cancel. The 1's cancel. So it leaves me this. So 4ah plus 2h squared plus 3h on the top with an h in your denominator. Now, because all the terms on the top have an h, I'm going to divide the h to the top. I'm going to cancel all the h's. So I'm going to have 4a plus 2h plus 3 when I cancel that. So there's f of a plus h. That's huge. Hang in there on that one. Sorry about that. I'm not really sorry because you're going to see it a lot. But that's the first time you've seen that. You're going to see it a bunch. We'll work on some of those tomorrow, so don't freak out yet. All right, last thing. Find the domain of each function. Only time you got to worry about domain is if there's a radical or a fraction, and I'm looking here at these problems, and all of them have one of those. So if there's a fraction, factor if you can. I'm going to factor the bottom of this one. Now remember what you cannot have. You cannot have a 0 in your denominator ever. So I'm going to go here. I'm going to say, okay, my domain for part A is going to be all x, such that x cannot equal 0. You can do this if you want to, or 1. And let's close it up right there. So x can be anything except for 0 or 1. Second was a little bit trickier. Radicals. Radicals have to be positive. So I'm going to take what's inside that radical, that 9 minus x squared, and set it greater than or equal to 0. That's what I've got to do here. Remember how we solved it the other day? We're going 3 plus x, 3 minus x. I'll factor that. Now remember, it has to be positive. So the other day we did this. We did a little sign graph down here. I put a negative 3, positive 3, because that's what the zeros are. I plugged in 100. If I plug in 100 up here, it definitely makes it negative for sure. So it's going to be negative, positive, negative. Now, because up here it says greater than 0, I want the part where the positive sign is, which is between negative 3. So the second part is going to be all x, such that x is in between negative 3 and positive 3. Okay, that's your domain. And the last one, just a tad bit different on part C. Let me change colors one more time. Part C, I can't have 0 on the bottom, and I can't have a negative in the radical. So I'm going to take the t plus 1 out. And this time, instead of saying greater than or equal to 0, I'm going to say greater than 0 because it cannot equal 0. So if I move that 1 over, t's got to be bigger than negative 1. So there's my domain. I'm going to put all t such that t is greater than negative 1. As long as t is greater than negative 1, you're good to go. And that's it. All right, that's quite a bit of stuff. A lot of stuff on functions. Don't freak out if you're not getting all this video. We will work on it in class. Make sure you get it before you leave the door tomorrow. So I'll see you then.